Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to redo the problem from problem number one, but I'm going to do it a different way. So the way that I did it before, there's nothing wrong with that way. It's a longer way. But here's another way you could do it that might be a little quicker. We're all using the same principle. So one of the things is that you can solve a question in multiple different ways and still get the right answer. So here again, here's the same problem as before. They give us the masses of oxygen and helium in the scuba diving tank. They give us the liters, the volume of the tank. They give us the temperature, and they want us to give the mole fractions, partial pressures, and the total pressure. So again, you're going to start out the same way. You got to get the mole fractions of the gases. So we're going to do that. So again, but you need to get the moles. So again, you get the moles from before. So you got 24.2 grams of the helium, and that's going to be 4.00 grams of helium on the bottom, 1 mole of helium on top. And again, if you've seen this before, I'm going to do the same thing, so you could skip ahead to the next problem or to the next step. But if not, then you should follow me. So grams of helium are going to cancel out, so now I'll get moles. I do the same thing for oxygen, 4.32 grams for oxygen, O2 gas. So then I get the molar mass. So the molar mass of O2 is 32.00 grams of O2, and then 1 mole of O2, grams of O2 cancel out. Now I have moles of O2. So I don't remember what they are. I think this one was 605. So 24.2 divided by 4 equals, so 6.05. So I have 6.05 moles of helium, and then I do the same thing here. I think it was 0.135, but let me double check. 4.32 divided by 32.00 equals, 0.135. So here I get 0.135, and that's O2. And again, 3 sig figs, so the sig figs are good. So if I add these together, I get 6.185 total moles. Okay, again, because I'm adding, I'm only allowed the least number of decimal places, so I have 2 and 3, so I'm only allowed 2, so that's the last one there. So now I can do the mole fractions again. So the mole fractions are going to be, so you got your chi, so mole fractions of helium is 6.05 moles of the helium over the total, which is 6.185 moles total. So moles cancel out. And if you calculate that, you get 6.05 divided by 6.185 equals, and then you get 0.97, so 0.97817. Again, because I'm dividing, I'm only allowed the least number of sig figs, so I have 3, 4, so least number is 3, so the 8 is my last sig fig. And then I do the same thing for the oxygen. And so again, I can either subtract from 1 to get it, or I can do the mole fraction. So if I subtract, let's do the mole fraction here. So I have 0.135 oxygen, moles of oxygen divided by the total 6.185 total. And so if I do that calculation. 0.135 divided by 6.185 equals, and that's 0.0218 equals 0.21827. Okay, so again, 3 sig figs, 3 sig figs. So I'm only allowed 3 sig figs, so it stops there. Okay, so now I have my mole fractions again. And so last time I found the partial pressures of each one using the ideal gas law. But you can actually find the total pressure first using the ideal gas law. And the way you do that is, if you know that the partial pressures are equal to, you use the ideal gas law, if the partial pressures of the, how do I say this? So you can, again, you can add all the moles together, and the total moles of the gases will give you the total pressure because of Dalton's law. So you can have total pressure would be equal to the total moles, right? And then you have total moles multiplied by R times T divided by the pressure. So instead of having the partial pressure equal to the moles of that gas, of that component, you could have the total pressure equal to the total moles multiplied by that. So we can add that we have the total moles. So if we put it into this equation, so then the total pressure, right, the total pressure is going to be equal to the total moles, 6.185 moles total, multiplied by R, 0.08206 liter atmospheres over Kelvin mole, and then you multiply by the temperature to 98 Kelvin, and then you divide by the volume, which is 12.5. So 12.5. Oops, that should be volume. 12.5 liters. Okay, moles cancels out, Kelvin cancels out, liters cancels out, leaves me with atmospheres. So if I calculate this, I should get the total number of moles. So I get 6.185 times 0.08206 times 298 divided by 12.5 equals, and I get 12.0997. So that equals 12.0997. That's the exact number I got before. So remember, I have 3 sig figs, 4, or actually 3 here because the 8 is the last sig fig. So 3 here, 3 here, 4 here, and I have 3 here. So the least number is 3. So 12.1 atmospheres is the answer for the total. I can then keep this to find the partial pressures. So now I can use the mole fractions for each, and then I can use the equation. So remember the equation, the total pressure is equal to, the partial pressure of the gas is equal to the mole fraction of the gas times the total pressure. So if I know the total pressure, then I can multiply the mole fraction by the total pressure to get the partial pressure. So I have the total pressure. I know the mole fraction. So the partial pressure of helium is going to be the mole fraction, which is 0.97817 multiplied by the total pressure, 12.09977 atmospheres, and that's going to give me the partial pressure of helium. And then I do the same thing. Partial pressure of oxygen is equal to the mole fraction of oxygen, that should be 0.02. This is 0.02. 0.021827 multiplied by the total pressure, 12.09977 atmospheres. And then if I do the calculations, so I do 0.97817 times 12.09977 equals, and I get 11.8356. So 11.8356 atmospheres for the partial pressure of helium. And if I do the same thing, it's 0.021827 times 12.09977 equals, and I get 0.264. So that's 0.26410 atmospheres. And so again, if I look at the sig figs, so remember that the 8, it ended at the 8 here and the 8 here. And so, and then for this one, it ended at the 0, so that's the last sig fig there, so the 0 here. So if I look at the sig figs, 3 sig figs here, 3 here, so I should only have 3 here, so 11.8. And then for here I have 3, so this should be 3 sig figs, so it should be 2.64 atmospheres. So those are the exact same answers I got before. So so either way gets you the same answers. This one is actually a little quicker because you solve for you use the one equation, the ideal gas law, to solve for the total pressure, and then you can use the mole fraction to solve for the partial pressures. Okay, I hope this was helpful. Thanks for joining me. If you like this video, share the video with your friends. Subscribe to the channel. Hit the notification bell so you can get notified by any videos I put out. And put a comment in the comment section and let me know what you think. Thanks for joining me, and I'll see you next week.